So Levi is a mining engineer at Maptek at the moment. He specializes in open pit blasting and all the data that comes with it, and that's also going to be his talk today. Before that, he was working on financial models in the mining industry. So I guess a bit of a different background, but you're probably going to hear more about how that might connect. Levi was actually a grad here at Colorado School of Mines. I'm not sure, are you still in the professional masters, or is that already concluded?
Yep, I've still got about a little less than a year. So don't tell Professor Spiller here that I'm not doing his homework. Don't rat on me.
Oh, we are recording already, so everybody can hear it now. That's too late. Sorry. But yeah, so it's awesome to have him here and have a grad here presenting, and I'm looking forward to it. I think a lot of people are too. So without any further ado, take it away, Levi. Thank you so much again.
Sounds good. Well, first of all, thank you, Lucas, and everybody who's joined, and thanks for having me. I'm really looking forward to sharing some information with you guys here. So let's just start out. Can you guys see my screen all right? I'm going to go ahead and go into presentation mode so you can see it here. How's this?
Perfect.
Great. All right. So the data behind blasting. Now, if you guys, a lot of you may know me, some may not, totally fine. We'll get to know each other here over the course of the next like 50 minutes or so. But I'm a very, I like to walk around when I present, and I'm not very good. I've done some demos and presentations over the screen here. But I really encourage you guys throughout this presentation, let's try to be a little bit more interactive. It's kind of tough to do online. I don't know if it's going to work. Maybe it's not, and I'll just ask rhetorical questions and answer them. But with that, kind of what we'll just go through here today, we'll talk about a little bit of an introduction, tell you who I am, if that matters. You guys can always put it on mute if you want, but give you a little bit of introduction there. From there, going to go into just the basics of blasting, kind of establish a little bit of a foundation so we know kind of the talking points here on the drill and blast. But then we're going to kind of get under the covers. We're going to look at the data that is associated with blasting. We'll do that in kind of two forms. I'm going to explain some concepts. I'm going to try to be short on the presentation. I do have a demonstration and essentially our blast management solution here at Maptek, just so you guys can kind of see some of this data, how it's organized, because especially for those who haven't necessarily gone into industry or early in their careers, as myself even, I think it's really important to understand what you've got available to you and how powerful it can be so that you can leverage it throughout your careers. So with that, and then, sorry, last point, I will do a Q&A. You guys have questions, though, feel free to sling them out. If we get too many, Lucas, let us know. We can keel off there and wait till the end. But I'm going to give the introduction that Lucas actually gave. So appreciate that. Like you said, graduate in 2016. A lot of these professors I see that have joined the meeting, had them through my undergraduate. And, like they said, you can't get rid of them. So I came back working on my professional master's. It's a totally online program. So I do everything from my home about 15 minutes away from campus here. I did right out of school, went to work for a company some of you may have heard of as Alight, got renamed to Revos, and then actually shut down a couple months after I left. So that was more on the financial modeling side, scenario analysis. And then after that, went over to Maptek, where I currently work. Started out on the mine design side, working in Vulcan, you guys may all be familiar with. But after that, we kind of, you get your experience in Vulcan and then move over to a specialty. And so mine was drill and blast, particularly on open cut operations. And so now I lead our drill and blast team essentially here out of North America, implementing our blast management solution. And so just to kind of talk about some of these pictures, I've been talking a lot today. I had a lot of meetings, so apologies. So on the top left, these are all places that I've been because of mining. So I like to share and brag a little bit, but some of it's not as cool as you may think. Like the first one actually is pretty cool. That's Punta Cana out of the Dominican Republic. I was there in February of this year. There's a gold mine that has our system that I was doing some training on. So sorry about that. So at that, spent some time at the end of the trip, enjoyed the beach there. It was really great. I loved it. Next to that is actually this picture up here. is probably 200 kilometers south of the Arctic Circle. Fortunately, I was flying north, so closer to that, towards the Arctic Circle there. So I have a couple pictures. Most of them I was spent time up there in the winter, but those pictures are just white and frozen, so not as much to see. Next, we've got down here is, this is actually in Alaska. Back there is a moose. You can't see it. That's all right. You can take my word. So that was down in Denali Park or something like that. Bottom right-hand corner is South Africa. Did a trip out there. Went to some coal mines east of Johannesburg and made a little bit of extra time to go on a safari. So with that, that's kind of some of the experiences just pretty much within the last year and maybe some change, you know, part of going through. And I really wanted to show the pictures of the operations and blasting and stuff, but fortunately because of confidentiality and stuff like that, I couldn't show those pictures. So the scenic tour will have to do. And so past that here now, we're going to get into blasting. So this is something that I'm passionate about. I love blasting. If you think about the process of mining, drilling and blast actually, while it may be a relatively lower cost center, the downstream impact of drill and blast is huge. And so with that, the downstream impact of drill and blast is huge. I'm going to go ahead and we'll try this interactive thing. Somebody, if you can unmute, take the floor and tell me why you think that drill and blast has a lot of downstream impact. Tell me ideas. Shoot, let's do rapid fire a couple here.
It's the beginning of the cycle.
It's beginning of the cycle. What else do we have? Anybody?
Basically determines the quality of the product you got to work with over the cycle, right?
Quality of, yep. So the beginning of the cycle, and it's dealing everything that goes downstream from here, right? That's the material you're now dealing with. So think of, right, your fragmentation, for example, crushing costs, your digability, how quick you can dig, right? Is that material going to cut through like butter, or are you going to have a bunch of chunky material? It's going to be a lot harder on equipment, right? So drill and blast is, well, I say it's a relatively small cost center, pump and powder down, fewer people, right? Less costs associated directly with it. Indirect costs are huge. So when I talk about blasting, let's talk about the concept as a whole. So where does that start and end? For the scope of this conversation, let's start out with one where you design the blast, right? So, and we're talking typically what I would call like the tier 1 operations. So like the Nevada gold mines, you know, Freeport, some of these bigger operations, right? So they're going to design a blast. Once you design it, you drill it. Once it's been drilled, then you have people that go out, they may tape the holes, is what it's called, basically measure out the total distance from top to the bottom, record that, maybe record water. There's other parameters that they can record as well. Then once you're on that pattern, you have the information for the holes, you're gonna load it, right? Fill it with bomb, explosive product, right? There's a bunch of different names, but you're gonna record all this product. And so now on those steps 3 and 4, consider the fact that you're not just recording this for one hole. A typical pattern can be hundreds of holes, right? So keep in mind that this has to be managed. Step 5, you blast it. Step 6, you dig it, you analyze, make sure things went well, and then rinse and repeat. So now let's take a step deeper and let's look at the data side. Let's talk a little bit more about, like, when we're drilling, what type of data exists. So now, for those who may have some experience, what data do drills capture nowadays if you're looking at some of these bigger sites? Anybody? That's all right. So what about the collar location, where the drill actually drilled a hole, right? It's going to be kind of important because as we get this information, how do we know how close we were designed to actual? So high precision GPS to find the collar. What about depth? What about even the angle to see essentially where that toe of the hole ends up, right? Taking this a step further now, we're drilling, right? Is all that, let's say that we're drilling a 50-foot hole, is all that material going to be the exact same? No, it's not. So there's a concept called measured while drilling data. It's a field. So in this, while the drill is drilling, there's instantaneous readings, readings that can be attributed to smaller intervals than one whole hole. So for example, let's take a coal mine. It's easy to conceptualize. So you're drilling a hole that you're trying to go until you touch the coal, right? When you touch the coal, that drill, as it's drilling, it's probably going to go through that, cut through that coal like butter. Super easy, no problem. However, when it's going through that overburden material, it's going to be a lot slower, right? So maybe you can look at the torque, the pressure, all of these different measured while drilling fields to inform geologic model, where the coal is, and some of these different characteristics, right? So there's drilling. Next up, like I said, we're going to load, we're going to measure a bunch of holes, we're going to put a bunch of product down the holes, and we need to record to the T a bunch of information. There's a couple primary though. One is explosive products. So how many boosters, detonators to make up a primer? So the things that basically initiate that whole column of explosive, right? These explosive products, but as well as how many kilograms or pounds of, let's say, ANFO, right? An explosive product is pumped down that hole. All of these aspects, super important to capture for regulatory reasons, for safety reasons, a bunch of this, okay? And then going forward to that blast, being able to understand how was, did we have fly rock, safety, okay? A lot of different aspects. And now you tell me, how are you, think about this in your head, how are you going to manage all of this data? What if I tell you now on top of this, that all this data, you've got a different design software, a whole different drilling navigation software, you're loading information you capture on paper or maybe through tablets, Excel sheets. What if you don't do post-blast evaluations, or if you do, it's pretty informal? How are you going to better inform the loop to improve? Okay, so thinking about this data, right? There's a lot that goes into it. I'm just talking about one site now. Now put yourself in a corporate position where you're the lead drill and blast engineer for this big company. Now, how do you manage that going down, right? Having data not only available, but available in a consistent format is incredibly key. And I'll speak to a case study actually here in a little bit to explain that in more detail. But with that setup, some of the pain points. So data is stored in different siloed systems. It's hard to bring all that data together to represent the whole drill and blast process. And you're going to spend, guarantee you, every time I go to site and we start talking about this, when I say blast management system or solution, we're talking about something that goes from A to Z, right? That design to the post-blast analysis. Most sites have like 3 or 4 different products associated with doing that. So that hurts. That takes a long time to manipulate, export all this data into multiple different systems. Okay. There's also the lack of digitization, right? How you capture that data really matters, especially if you're physically handwriting information. Like out on the pattern, I've seen people writing hole depths on stakes. If you do that 200 stakes in a course of a day, are you going to have your handwriting readable on all those? I don't know about you guys, but my handwriting is hardly readable anyways. So things to consider there, right? There's a lot of pain points. I'm going to go down to this bottom one, but understanding if issues stem from blast designs or conformance to design. So let's say, put yourself in a manager's shoes. That's important, right? You're managing this drill and blast operation, and you just had a huge fly rock incident. You had a near miss where fly rock went past the radius that you cleared, and you have to determine why. First question, one of the first questions that I would ask at least, was it the blast design or was it the conformance to design? Until you go, oh, we need to change our blast design, take a step back and look at how your design was executed. Too often, I can't tell you how much time, when I'm on site, I spend, maybe like 30 to 50% of my time out in the field. I can't tell you how many times engineers say, oh yeah, they're giving us 16 feet of stamen. They're freaking on it. They got this thing dialed in. I go out to the pattern. So what are you gonna do in this case? 13 feet of stemming confinement, right? That's material on top of the hole to hold down the powder. That's fine, we'll just go with it, right? So there's these little things that is important to understand, okay? And so let's put this data into action. And I'm gonna go through this super quick here. Let me know if you have questions. I'm gonna go through this quick because I want to more so show you than tell you in the presentation, okay? So look at this picture. Ignore the bullets for a second. Just look at the picture. Do you understand what happened here? Without even knowing the software, anything behind, do you understand what happened? Why are we seeing that there's this big area? I'm pointing with my finger, that doesn't help. Why do we see this big area in red here?
They didn't drill to depth.
Yeah, for some reason, either maybe they didn't drill to depth, maybe there was water here which caused them to lose their whole depth, but something happened which ultimately led to some hard toes, some material there that they couldn't dig out. It was probably a pain, maybe cost them a shovel tooth, lots of other consequences going downstream, right? But these are the things that you need to be able to visualize your data, have it captured so that you can quit, because it's easy for us right there. You just in your head probably identified there's an issue, here's what it is. So for some reason, we didn't have enough powder deep enough that caused a hard toe. That is very valuable. Getting the data in this format is really important. And so some of the stuff that, and I'm going to show you this here in a second, so I'm going to go through quickly, but just consider once you start understanding what data you have available, then you can go in and to begin to solve problems, begin identifying who's your best, who's your worst. Is it who's most popular, who you talk with the most, or is that the quiet fella in the corner who actually is our best driller, and we need to get him not only training people at our site because he's bang on, but we're going to send him to the other sites for collaboration training. And same with, right, when you're out in the field, knowing how much bomb to put down the hole and the stuff. We'll get here in a minute. But also on the vibration fragmentation side, you know, I think there's a couple iconic mining pictures that maybe you guys have seen, maybe not, but there's this big pit, and right on like the crest, you see it like a whole sprawling town, right? You can bet that vibration is an issue. And you can bet that people call in who have those houses, and they're probably saying, oh, maybe there was, today's blast was terrible, you cracked my foundation, something fell off, blah, blah, blah. I've heard of those cases happening at sites. I've actually got experience with these very comments. So recording that information, keeping a record is incredibly important. And after the blast here, it is going along with the same thing, using the data to understand what went well, but also what didn't go well, to reiterate and make your process better is incredibly important. And like I said, having the data in one individual spot allows you to make a whole lot more correlations and trends than you would otherwise. Okay. And so with that, we can drive continuous improvement. We could talk about dashboarding and all that good stuff. But I want to fast forward to a case study here. So this was an actual implementation. I participated in some of it, but essentially it was a global implementation at a large company of our blast management software. So with that, we saw 142,000 holes in 6 months. Now I started talking about just a little bit in concept, some of the data that's associated with each of those holes. But keep in mind that a 23% improvement by being able to manage your data, manage it in a single system with transparency and doing it across multiple mines, that is a massive undertaking. And when you look at those numbers, that translates to more than just millions saved. I was actually talking to a client the other day who said just this year alone, because they've been able to, and this was for drill and blast improvements overall, improve their drill and blast process, they've saved $80 million this year. Of that, 40 million was just resulted from better fragmentation. So keep that in mind, that while data, it's a hot topic, there is a lot that you can talk about on this, and oh, it's cool. When you use it correctly, it's a very powerful thing. And so what I'm going to do here is I'm going to transition over. I think we're still doing good on time here. So let's have a look at this. All right. So I'm in a Maptek software. It's called Blast Logic. That doesn't matter. I just want to show you, because this concept reigns true in a lot of different areas. But I'm going to try to take you through a story. I want to do this somewhat quickly because I do want to leave time for questions here, but please feel free if we need to go into something a little bit more deep or whatever, just let me know. So I want to put yourself in the position of a drill and blast engineer. Okay, you're working at a surface gold site, middle of Nevada, coolest place to be ever, right? Some people say, but we're out there in the middle of Nevada, okay? You you just finished up this design, it's being drilled, okay? So let's have a look at some of that drilling data. So I'm gonna go ahead and we're gonna pull some of this up, but keep in mind that the data that we're about to look at here, this has been cleaned, okay? When you're dealing with raw drilling data, it's essentially a huge database. You can't find anything. There's a bunch of null and blank fields, but have a look at this. Okay, so take a second. Let's walk through this. So this data represents information that was sent directly from the drill navigation system. So that might be EpiRock Surface Manager. That might be Wenco. There's a lot of different options and providers out there, but those drills that are capturing all that information, they store it in a database, and now we are going to pull it, do some validation, which I'll talk about in a minute, and then use it, okay? So looking at some of this information, remember earlier we talked about X, Y, and Z coordinates? Why would we need that? Why is that important? How are we going to utilize that data? Does anybody know? That's
accuracy for design.
Bam. All right. Thank you for that. I don't know who said that. It makes it hard, but thank you. So on that, you're absolutely right. Did it get, we may have designed it here, but if it gets drilled way over here and you have a problem on that pattern, right? Was it because maybe two holes were too close together, right? You didn't have sufficient burden, all this stuff, sympathetic detonation. There's a lot of concepts there that we can talk about, but in essence, design, drilled, doesn't match, okay? And so what you can do is you can apply, I'll say an algorithm. I don't like to say that. I don't know why I did, but you can apply basically some simple rules to say, all right, if I have a drilling event as well as a designed hole, and it's basically close enough, you know, if the collar is close enough, if the depth is close enough, then essentially what I'm going to do is I'm going to say, yep, this hole represents this drilling event, okay? So now that concept, as a drill and blast engineer, you're seeing one drill's worth of data for essentially half of its day, right? One shift, 12-hour shift. Take this to a big mine. They may have 5, 6, 7 drills, more than that, drilling 40 plus holes a day, probably not stopping, right? So this data can get to be a lot and you can get behind quickly. But what we need to do is have a way to quickly sift through and manage it. And I'll show you why here later down the stream, but I'm trying to build a foundation into some of these concepts. So let's just have a look here. I've got a button, it says auto validate all. Basically what I'm doing, I'm running through a set of tolerances, okay? Everything's looking good. Although I see I do have some red here. Let's have a look into this. All right, I can see pretty quickly here, well, this drill depth was 0.1 feet, but I have another drilling event right after it, 54 feet. Okay, something maybe happened. They started the hole and then whatever reason, bio break, whatever it is, doesn't matter. They stopped, restarted. So this is the information that if you just use raw data that hasn't been validated, this is going to mess you up, screw you up. I've seen holes that are being drilled up because they started the hole when they were coming up, right, with your steel. And so there's a lot of data that needs to be cleaned. Okay, so we talk about big data, but with data, garbage in is garbage out. You need to make sure that you're working with quality data. And so let's say that to fix this, I'm just going to real quick go through, take a second, and I'm going to go ahead and just make sure that I reassociate, do a couple steps. I'm not going to go into big detail here, but essentially 2 seconds, 3 seconds, I've got my data sorted. I can go apply this. I'm happy. We can continue on, make sure everything looks good. And I validated that data. So one step in this process. Now, do any of you notice a subtle difference that occurred on my screen here? So you may have noticed that the holes previously were like a magenta color or pink, whatever. Now they've turned to blue. So the important aspect of being able to deal with this data and deal with it in real time. So as drilling events are happening, getting validated, recording that, right? Having this visualization as a drill and blast engineer, having that come through visually, right? You can have this pattern up, you can see when it's getting drilled in real time. That's the cool aspect of working with data, but doing it now. So to take it a step further, right? We've designed the pattern, we've got it in. The next step, right? We've drilled it. Now once it's drilled, we're going to apply some charge logic. And I'm not going to go really far deep into this, but just as a conceptual understanding here, because I think it's important also that you guys understand the drill and blast process. So I'm kind of trying to tailor to a couple different audiences here. So sorry if it seems a little scattered, but keep in mind that we have to say how much powder is going to go down the hole and in what situations and scenarios, right? So just a super easy example. Let's say that I've got a hole that's less than 13 feet. I'm going to fill it with just dirt. I'm not going to put explosives in. That can represent a hazard. Why? We can talk about later. But then if, let's say, we've got a hole that's longer than 33 feet, we're going to allow for basically a fixed stemming, so a fixed amount of confinement, fill the rest of the product with explosive material. Okay, just so that you guys are familiar, this is how some of that charge logic, those charge rules are applied. And with that, why don't we take a field trip? So we've been working in the office. We understand kind of what's going on in the background, but now take yourself out to a pattern, okay? So I'm going to open this up. And let's say that we're out on that pattern and we're getting ready to put explosives down a hole, okay? How does that data get recorded? Because if you understand what that data is getting recorded, you can understand how to use it. So let's go ahead and have a look at, we'll just go to a pattern. And again, guys, I apologize. I am going through this somewhat quickly, but I want to make sure that we kind of get some of the core concepts down here. But so you're out on this pattern. This is what it looks like. No problem. We're over here. Let's say that we pull our powder truck up and we're going to load this row right here really easily, right? Being able to capture this information, enter it in, go on to the next hole. Maybe we need to update the depth. You know, we remeasure it, whatever it may be. That makes some changes based on the charge logic, right? There's a lot of stuff that goes into this, but seeing and understanding this process is critical for you all to understand here in a minute how we can utilize some of this, okay? But so let's say that you've gone through and you've loaded this pattern, right? This is, again, you're out on the field, you're recording this, you've got a tablet in your hand, and you're really quickly entering in this information. It's pretty easy, okay? You synchronize that data back. Sure, it's all sent, but this is all feeding. Sorry, if I take a step back here, you'll notice that this synchronizes every 5 minutes. So you're, again, getting that near real-time feed of data back, okay? So now take a second here, pause. As a drill and blast engineer, what can I do with this data? Because chances are previously, if you don't have a system in place that allows for this input syncing using that input network, you're not going to have this information, okay? Let's talk about an example. Let's say that I've gone through and we measured and there was a hole that was too short. Maybe this allows us to bring in a drill for a re-drill, okay? Sometimes if a hole is too short, you know, because it can affect essentially fragmentation because you have a hole that maybe can't be loaded or it doesn't have enough powder, they're going to run a drill in, drill a replacement essentially, right? Go on. So there's some operational aspects to this as well that not necessarily going to focus on as much, but there's a lot to this concept, okay? So if I quickly come back here, I'm going to switch over patterns. And let's just look, let's take a visualization into the charge decks here. So what we're looking at here on a pattern is essentially, all right, so I'm planning on this purple is our explosive product, right? This gray is going to be our aggregate, our stemming and the such. But having that visualization, being able to quickly go through and ultimately like that picture I showed you earlier, being able to determine where that hard toe is, why it happened, using that loading information, visualizing that, it's all incredibly important, okay? And so taking that one step further here is doing some quick reporting. So one of the concepts that I think is easiest to understand, especially when you're first starting, is drilling. So let's say that, oh, I don't know, we'll look at a pattern here and have a look at these numbers. So this is our drill depth accuracy. Okay, this goes into having data available and making it actionable. If a drill depth is short, basically represented in red, right, this is your distribution. Okay, so it's the number of holes that are within these intervals, right, going forward. So what if I take this and I sort by operator? Let's see how Jeff is doing. Let's see how Jane is doing. You can start to see that this shift, and oh, hold on, Jeff, you've got a lot more short holes than Jane. So this can influence, because you have this data available, it's been validated, so you know you have quality data, just like we talked about earlier. You've got quality data that you can make actionable, run your reports, provide this to supervisors, to your improvement team, and ultimately start making that improvement, in this case, in your drilling. Consider the same exact concept of taking this and doing that on the charge side. How many kilograms did we plan, or pounds did we plan to load down this hole? What was actually loaded? Is there commentary into why it was loaded differently? So on and so forth. Okay. So I think this would be a good opportunity. Let me pause here and see if we've got any questions. Questions on the technical side here.
You're going to go into maybe more autonomous drilling solutions, because a lot of those things are, not a lot, but at least the operator specific parameters seem to be geared towards manual drilling, and maybe differences in autonomous drill rigs, what you would be looking into in those types of situations. Sure.
So autonomous drilling is actually it's kind of interesting, because we think it just works, right? But I was working with an operation that was kind of trialing out this autonomous drill. and I laughed because they said, our autonomous drill is stupid. And I had no idea what that meant. And so what they said is, if we put it in rock type A, it will drill perfectly all day in that rock type, because we've got that drill, we've got it zoned in, and it nails it, right? So this distribution, it's going to look pretty much perfect, beautiful. They said, but it's stupid, because when I go to a different material type, the results are everywhere. It shuts down, it won't work, it gets confused, it does things that we wouldn't expect it to. So while autonomous technology is great, and there is a lot of benefit to be had, I think there's also a lot of challenges that we're currently seeing. And so while we would all expect to see, oh, well, operators, whether that be, they have mistakes and autonomous drills won't, chances are, from what I've seen, which is relatively small, it's not been super huge at a lot of the sites in North America that I've dealt with. But it's not it's not quite there in terms of being the perfect solution that's going to give you perfect results. Does that answer your question there, Lucas?
Yeah, totally. Is Maptek planning more on like interfacing with such equipment? Is that something that is relevant for Maptek, or is that more on the? So what I see from, at least from my underground perspective, is I think there's a lot of companies who start using those exact or different types of data, but they start using equipment data and do their stuff, and then even companies that haven't really been in the field before, they just emerged and start doing stuff with that data. Then the OEMs are doing their own programs. Is that something Maptek itself was interested in getting on board, interfacing with autonomous equipment more, or?
Yeah. So typically when you look at interfacing, on the drill and blast side, where we sit is we're more so, we don't want to control the drills. We want to take their data. So we wouldn't have necessarily like a direct relation with the drill itself, but we are dependent on basically the database that the drills send all the data to. So in that regard, we do, we integrate with those today as we speak. We just take the data that's captured, but really Maptek, we're not in the hardware side of like turning a non-autonomous drill into an autonomous drill or something of the such.
So just a question there, Chris Johnson here.
Hey, Chris.
Hey, how you doing? Long time. Just so on this data you're presenting here, was that like downloaded for the rig, or did that rely on manual operator entry to gather the data sets?
Yeah, now that I love that question, because the data that gets brought in here, it all, like when you're looking at the drilling, it all happens automatically, because that's a big deal to go to a database, manually do exports and then imports and try to match everything up. So we essentially have an integration service. We call it Bliss. So Bliss will automatically pull this data in. It does, like I would say at a good site, about 95 to 97% of the validation for you. So that way you're, it saves you a lot of time, and we all know time is precious there.
Yeah, so just wasn't exactly the question I was asking, but that's still good information. So just looking underground, a lot of rigs don't have any sort of smart capabilities, no real computer on them. So in that case, would that be the operator would have to log down the information, how deep they drill, how long it took to drill the hole, that kind of stuff, and log it onto a tablet or something like that?
I see. Okay, I see your question now. So my focus is definitely more on the open pit side, where we're dealing in a little bit different of a dynamic. This solution that we're looking at now only is applied to open pit senses. I know that there's some R&D, I guess, so to speak, around the underground solutions, but I'd say that there's open pit solutions first, for one of the reasons, as you're mentioning, is that there's some network connectivity and technology challenges that are associated with underground. So I guess the short answer is I'm not sure at this point how we would take some of that information down. I know that it is possible to basically record start and time if you have the drill depth as well. You can't always record that manually, but it also has to be realistic to do some of that as well.
No, that makes sense. So then you do rely on a smart system that does record the data, and then you interface with that database to harvest all the data. Is that right?
Exactly.
Okay.
Thanks, Chris. And if you guys have other technical questions, I've got a little bit more material now that I can go into, but I'm happy to take, if you guys wanted to see anything, like whatever it may be, feel free to ask some questions. I try to give a little bit of an opportunity just in case we get a few here.
Levi, how are you in incorporating this with the ore control, Polygon generation?
Yes, so it's, Dr. Daglin, it is incredibly important. A good example, I was at a diamond mine, and so fortunately on the grade control side, it's pretty easy to see, because you're out on the pattern and you've got this big black, very dark material kimberlite pipe, and then there's a pretty defined content to your, just regular gray material. So when we're looking at that, that really should and does a lot of time get integrated throughout the design process. So considering, where that ore waste contact is, how you can, basically minimize dilution, movement, some of those different aspects, and, also on timing. So that definitely is an input and a consideration. And we do have basically special ways of capturing some of those custom properties. And even if you wanted to look at like what holes have been sampled and stuff like that, I would say it's a huge concept for the mining industry, and we are actively involved in that.
Great. So it is. It goes with this. It doesn't stop here. You talked about siloing. You have your blast design and making it efficient, and how this this round is gonna blast, and what is your ore waste interaction, the dilution coming from this blasting step, and taking into account in 3D and generating your ore waste contour polygons, and so you're just looking at the drilling and blasting here, and not incorporating it with the ore control.
Gotcha. So kind of the last aspect that I really focused more so a little bit earlier stage for the purpose of this presentation, but there is kind of that post-blast analysis, especially when we look at like, I mean, you can even, I've worked with clients on photogrammetry looking at, you know, basically the fragmentation with each scoop of the bucket, associating that with spatial data, incorporating that in here. You know, it's those same concepts of, you know, especially if we have spatial data, so movement of contacts, we're able to take that data, consume it, and then throw it in. Like one way of consumption might be a heat map, for example, or extrapolating to different holes and making some custom reports on that aspect. So we do a lot of work in there, although I didn't explicitly demonstrate it here. I think that's one of the, you know, one of the big values of the drill and blast process as well.
Great, thank you.
Of course. Any other questions here before I go through the last little bit?
And again, one more. Can you incorporate the information coming from blast monitoring balls into this program?
Yep, absolutely. So I was working on a project a couple of weeks ago, actually, where they had basically these individual holes that were drilled in the middle of the pattern. And you know, those are they call them BMT holes, or the blast movement technology. But essentially they put these holes down, or these balls down the hole, shot goes off, they kind of track basically using a signal from that where it's gone. So that absolutely is additional information that we take in, and you'll even see those holes. I don't have it modeled in this particular example, but modeled within Blast Logic to manage those readings as well.
Nice presentation. Let me ask you a question. Early on, you mentioned that there are, while drilling, you can actually characterize the rock, essentially know what rock conditions you're going through. Mm-hmm. Are you talking about Thunderbird system? Is that what is being used, or are there other competing systems for characterization?
So I'm actually not familiar with the Thunderbird system itself.
Okay.
But essentially what you can do is there's logic that you can apply, and there's some like black box theories, but also just like in the simple sense of, you know, if you're drilling through this much material and you have a pen rate, I'm just going to keep it simple, 1, but the next material is like 3, that's indicative of maybe a material shift change, and maybe you've got layers, sedimentary deposit, you know, whatever it may be.
Sure.
That then, you know, extrapolating that now to blasting, that would be important for us to say, we don't need to pack nearly as much of a punch in that soft material, but in those hard bands, maybe we do want to add a heavy ANFO, or maybe a product that's more dense to essentially improve that fragmentation without just totally destroying these weak areas that take up a lot of your product's energy.
Okay. Because yeah, Thunderbird essentially does that. It keeps track of the penetration rate, torque, and then deciphers what type of rock it's cutting through, and actually offers a 3D map of the ground.
Yeah, exactly. Same concept. I just hadn't been familiar with that particular instance there. But yes, absolutely.
Thanks.
Of course. All right. So the last part here, right? I kind of showed you, we had a little bit of backdrop. What is blasting, right? What's the data behind it? And then as we've gone through, you've seen some of this data, and now we're kind of talking about how to use some of it. But again, I'm going to stick to drilling here, and I'm actually going to go outside. I'm going to go into Power BI. Some of you may be familiar with Power BI, but essentially it's just, you know, this isn't a Maptek tool, it's Microsoft actually, but a way to consume data. So it's really important, and this is something that you all should be aware of, is that when you're on site, you need to own your data, right? It's not the, in my opinion, it's not the vendors, right? Like Maptek, we don't own your data, it's your data. And so you should be able to take that data, put it into another system, source, whatever, and manipulate it how you want to. Because ultimately, I guarantee you that every single blast operation in the world does something different than everybody else in some way, and that no one wants the exact same outputs, right? So there's a customized reporting aspect, particularly based on, you know, what management wants to see, what the supervisors want to see, and so on and so forth. So let's, for example, keeping in the vein of drilling, let's look at a driller scorecard. So, I don't know, let's see, within this date, we've had basically 3,000, I think this is meters, 3,000 meters drilled by each of these operators, okay? And now we can start to evaluate on an objective basis, right? This is validated data, so good data. Now you can start to compare your drill operators. What's your guys' guess? Do you guys think operators like this or don't like this overall from what I've seen? What's your guess?
They hate it.
They hate it, okay. Anybody think they like it?
I think they actually like it. I think I hear it from people saying that they kind of drives competition, and like in most cases. I'm pretty sure there's people that hate it, but I could see how that can be an incentive to compete and get better, and or even just improve, right? Just generally for yourself, not even competing, but just becoming better at what you're doing.
Heck yeah. So I know a drilling supervisor.
If they come from same family with the same last names, I don't know.
So I know a drill and blast supervisor that takes this dashboard, takes it, prints it, puts it right there on the wall, right where they meet every morning, and they use it as competition. Now, that particular crew, they've got a really good rapport, and they're all super competitive, right? So as Lucas is saying, they're like, all right, let's go, right? You're driving competition now. You're using your data, which you really can't refute, right? The drill captures this, so it's the real deal. And you're using this to drive competition. Now, the people who don't tend to like this, if you can imagine, maybe some of the underperformers or those who, you know, aren't performing as would be expected because it's being identified. So this actually, and I think there are certain people maybe that less competitive, you know, don't like it, but overall operations have really used this as a motivating factor. And then also to identify retraining, right? So like if you're caller, for example, right, if you're drilling to the right, you know, every time on the hole, maybe you just need a little bit of an adjustment, some feedback to let you know that, right, there's some corrective action to help you improve. So a lot of this has actually been taken really well. And so you take this same concept of a scorecard and you apply it to not only drillers, but also the powder truck operators, MMU operators, you know, those who are loading the holes itself. And then you take that same concept and you apply it to just a blast in general, right? So how did we do in terms of our fume, right? Do we have any bad gas, NOx, if you guys are familiar with the term, right? And so taking these scorecards, applying them with data that basically fills all this out for you. So all you have to do is say, all right, my date range, okay, let's look at Jeff, Jane, all right, right. Quick comparison, easy as that. That's important. So these concepts, while I'm showing you driller scorecard, keep in mind that they're the same concepts apply to loading, to a blast overall, and then even your post-blast analysis to see how we did as an organization, which you should use to drive improvement and to make your operation better and achieve that $80 million savings that I was talking about earlier. That's where you're going to look really good in the eyes of your employer, and they're going to be really happy. And I think that'll pay for most of your wage, at least for the year. At least I hope so. But with that, that was kind of the last concept that I wanted to leave you with. So I think we've got 7 minutes or so. So open it up to questions, and if there's none, we can end early, no problem.
Yeah, Levi, Chris again. I've got a couple. At the beginning, actually, I'll give you the easy one first, or a comment. It was I saw at the beginning something like 125% improvement in stemming. And is that just a case that actually somebody's watching them? And so, you know, where normally people don't watch because they usually don't like to stem.
Yeah. So on the stemming, the most common case that we've seen is when it wasn't monitored. There was especially from my experience, there's a huge disconnect between what they say in the office and what occurs in the field. So some of that I think is just a communication issue of like the people on the pattern thought one thing, you know, that maybe tolerances were a little bit looser. They were okay with some variance. Other aspect to this as well is just kind of coming down to, like you're saying, monitoring. A lot of operations don't actually measure what that stemming confinement column is, which is really, when it's not being monitored, enables some loosey-goosey practices to start to occur. There's some accountability held now.
Okay, well that's fine. A bit of both. The other question is, earlier on you said, you quoted something about an $80 million saving. How did you measure and determine that?
Sure. So actually, I didn't do any measuring. This was directly from the mouth of the client. There was, from what he said, there was 40 million associated with improved fragmentation, which has helped increase throughput and consistency through the mill. Being a gold operation, especially now with prices, that really helped them take advantage of this price, the gold price. And the other 40 million, he said, was due to some other initiatives. And they also changed a powder provider, which allowed them to use some different powder and the such. So there's a lot that goes on there. But my understanding is that his QA/QC of the data and basically how their performance was tracking allowed him to make those quantifications. Thanks, Chris. Any other questions here?
And this was in Microsoft. What product did you say you presented this?
Sure. This is just Power BI. Business intelligence, I think, is what the BI stands for, but
okay.
Pretty standard. You can take in data and run with it, chart it, do what you like.
So I got a question, kind of going back to the autonomous drilling. I mean, correct me if I'm wrong, but a lot of this, especially the driller scorecard stuff, would seem to me that that's really what a lot of the OEMs are also kind of looking for, right? If you start collecting all that data, make it nice and comparable and consistent, that basically gives you the ideal tool to say when it's worth switching over to an autonomous drill, right? It's a really powerful solution to put an exact dollar value on your drilling performance and evaluate that against an autonomous solution or something else.
Yeah, that's great insight. You know, having a financial modeling background, right? Building financial models for mining customers, the biggest pain point that I had is, you know, they don't really have, you know, they have very high level data. Oh, we moved this many tons in a year. But, you know, in some of these decisions, I was on projects to evaluate switching to autonomous haulage. But some of that evaluation gets really challenging because of the lack of data. So like you're saying, Lucas, being able to quantify through the data, basically the loss, like for example, over drill meters throughout a period, quantifying that is a really good way to start justifying and pushing some of this autonomous technology over the line and saying, this is the point at which it makes sense. So great comment there. Any other questions?
How many operations use this blast logic?
So globally, we're at over 80 operations. That's Australia, Africa, even got some in Europe, North America, and South America. Pretty much everywhere, Asia as well.
Do you find it difficult to try and get, you know, operations that already have Vulkan, use Vulkan for drill and blast design, but just trying to get them to add the extra license for blast logic, or is it pretty simple?
Yeah, so we've got really great integrations between Maptek products. So if you have your design and you want to pump it over to Blast Logic, it's super easy. So the friction with a Vulkan client to implement Blast Logic is actually, it's less. It's easy. They've already got a little part of the process done and it's going to flow in really nicely. Otherwise, it's a CSV import, not that hard. But really, it's just kind of tackling a different problem than Vulkan, I would say. It's more of the management and data capture, big database, you know, in some sense as well. So it's kind of in two different ballparks.
Hello, Levi. It's Joe here. I was wondering, what is the next big step for blasting, assuming that everyone's going to automated drilling and loading?
Yeah, the next big technology step, that's a great question. I've actually seen some technologies like autonomous drilling and stuff like that. And I do believe taking the operator out of the cab is going to be a big step. But I don't have a clear answer for you yet. I've got some ideas that I've seen, but I think the next step is going to be your autonomous equipment, right? Taking people both out of harm's way and also automating some of the process. But I think it's a little bit further out than some indications that I've seen, just because, like I said, the new autonomous drills are stupid, according to one source.
Thanks.
Of course. And so if we have any other questions, feel free to shoot. I do want to pop over here. There is my contact information here. You guys can reach out to me via email. If you guys have follow-up, want to chat or the such, or Lucas, if we still have time for questions, we can field them, or if you're ready to cut off, feel free.
Yeah, if there's more questions, we're happy to take it. I'm gonna be hanging around a couple more minutes, but otherwise
Excellent.
We're exactly at 5 o'clock. So again, thank you everyone for joining us today. Again, if you have questions, just shoot, and I hope we see you next week. Muthu has some details on the speaker next week, maybe you can share. And again, first of all, thank you so much, Levi, for joining us today. It was really appreciated, really grateful for that. And hopefully next semester or next year we can have in-person seminars. Maybe not next semester, but sometime in the future, gonna have you here in person and do that again.
Sounds good. Appreciate it. Thanks for having me.